Hello guys, we have here an example of a design of singly reinforced beam, and we have given a task to use the WSD method or the working stress design. So without further ado, let's start. A reinforced concrete beam 550 mm by 300 mm with tension reinforcement of 5 to 28 mm in diameter bar is simply supported over a span of 6 meter with additional 2 meter overhang from the ride support. Using the effective steel covering of 65 mm, FC is 28 megapascal and FS is 138 megapascal. Calculate the moment capacity of the beam. So, the first thing we do here is to draw a diagram. But as you can see here in my Excel, I didn't put my drawing here since I draw it on a scratch. Well, you can do that on your own. So, the first thing is to deeply analyze the problem and identify what is the given. So, the number of main bars n. So we will find the number of main bars. So here, the 5. So we will put 5. The beam width. So the beam is 550 millimeter by 300 millimeter. So the width is 300. The effective depth. So 550 millimeter minus the 65 millimeter here, the 65. So we will get 485. And the effective steel covering. So using the effective steel covering of 65, so 65. And the FC here 28 megapascal. FS 138. And the diameter of the main bar here, the 28. But as you can see, if we input all the given here, it will automatically give the answer. So, in getting the steel area, you have here the formula. N or the number of mean bars times pi over 4 times d squared. The d here is not the effective depth. Instead, it is the diameter of the main bar. So 5 times pi over 4 times power d20 or the diameter of the main bar squared. So we will get the answer of 3078.761. So next is the modular ratio. Modular ratio is ES over EC. ES is equivalent to 200,000 and EC is equivalent to 47 square root of FC. So in getting the modular ratio, 200,000 divided by 47 times square root of the FC. And we will get the answer of 8. Next is the moment at NA or neutral axis. In getting the value of C, we will using a we will using quadratic formula here and simplify it to get this. Okay, the first thing we do or the first thing I do is to calculate the inside or the NAS here, the NAS. So as you can see, I have already calculated here, as you can see on the screen. So, N, or the modular ratio, times steel area, and we will get the answer of 24758.77029. The next is to get the 2NAS, 2NAS BD. The B here is not, I mean, the B here is the beam width. So, 2 times modular ratio times steel area times the beam width times the effective depth. So, we will get the answer of 72048025154. So, the next step, or the next thing to do, is to calculate the inside, or to calculate the whole inside. We will get, or we will minus it, NAS squared minus 2 NAS BD here, let's see, and we will get the answer of 72047777395. Here minus here, 2 NA, or NAS minus here. After we get the inside, we will proceed here. The first NAS. So, modular ratio, negative modular ratio times steel area plus square root, the answer of our calculated kanina. So, here, the inside. So, square root inside, square, close parenthesis, divided by the beam width. And we will get the answer of 200.40729995. Next is the moment of inertia at neutral axis, or the INA. To get INA, the formula is B, or the beam width, times C cubed, here the C, over 3 plus 8AS, close parenthesis, D minus C squared. So, 1/3 times the B, 300, times power of cube, the power of C cube 3 plus 8 plus times the steel area times power of D minus C squared. And we will get a answer of 27997.62270. Now, we will get the concrete, the moment capacity of the concrete. So, in getting the concrete, for the MC is 0.45 FC prime, equivalent to MC over INA. So, 0.45, I simplify it into this. 0.45 times FC is 28 times E26, the moment of inertia at neutral axis, or the INA, divided by C, 100. And I divided it by power 10 of 6 in order to get a kilonewton meter answer. So we'll get an answer of 176.0265. Next is the steel. To get steel, we'll follow this formula. Fs over N is equivalent equals to md minus c over ina. So to simplify or to simplify it, um, Fs divided by modular ratio modular ratio times the ina divided by the effective depth minus the moment at neutral axis or the c. And to get the answer of k and m, we'll divide it at 10 power of 6, and we will get the answer of 168.8198. So the moment capacity of this example, or the moment capacity of the beam, is the steel. So that's it. Thank you.